This nutshell looks at the C language operators, selection and iteration control structures, functions, and libraries. If you do find this nutshell useful, please support the channel by liking and subscribing. C operators are symbols that are used to perform an operation on variables and values. The operators are grouped into types, 4 of which are arithmetic, relational, logical, and bitwise. The arithmetic operators are simple mathematical functions. However, there are 3 operators you may not have used before, which are modulo division, that returns the remainder of the integer division, increment, which increments the variable by 1, and decrement, that decrements the variable by 1. Relational operators are used to compare 2 values. If the comparison is true, it returns a 1. If the comparison is false, it returns a 0. These operators are normally used in conditional statements such as if, while, and for structures. Here are some examples of relational operators. In the if statement, if A is greater than B, if that's true, execute this line. If it's false, execute this line. Or, while A not equal to B, you will stay in the while loop while true. So while A is not equal to B, do this. This is an example of the wrong use of the equal sign. It should be double equals, so a mistake has been made, and this code will not work as you expect. Boolean logic is used in both logical operators to combine multiple statements and a conditional statement, or bitwise operators to set, clear, or test specific bits within memory or registers. This is known as bit masking. The truth tables here show the AND, OR, and exclusive OR Boolean functions. True and false. A number is true if it has any value other than 0. 1, 10, 100 are all true. A number is false if it is 0. Logical operators are used between 2 conditions or 2 bytes where the entire condition or byte is considered to be true or false. The logical operators are AND, OR, and NOT. Bitwise operators perform Boolean logic on each corresponding bit of 2 bytes, e.g. bit 7 of 1 byte is operated with bit 7 of the other byte, bit 6 with bit 6, etc. Therefore, Boolean logic is performed on individual bits of the byte. The bitwise operators are AND, OR, exclusive OR, one's complement, shift right, and shift left. Some examples of Boolean logic are shown here. We show the initial variables num1, num2, num3, and we can go through and look at the logical operations, which give a result of true or false, and the bitwise operations, which give binary results. Looking at the selection statements if and if else, the general form of the if statement is the if command followed by a test condition, and the curly braces here to show the code that's within the if statement. If the test condition is true, then we execute the code within the braces. If you don't have the braces, then only one line of code is within the if statement. Now we have the if else. The general form is if command followed by the test condition, the curly braces to show you what code will be executed if the test condition is true. Then we have the else with the curly braces to show what block of code is executed if the condition is false. So we can see an example here. If number is equal to 0, we execute this code, else we execute that code. Similarly, if we don't have the braces, then only one line of code is included in the if and one line of code inside the else. Two if-else structures are the nested if and the if-else ladder. The nested if has if statements inside if statements and can be used to evaluate multiple conditions, with subsequent conditions only checked if the previous condition was true. In this example, if this condition is true, then we will look at the second if-else structure, else if it's false, we will jump out of the nested if. The if-else ladder evaluates multiple conditions, beginning with an if statement, followed by a ladder of if-else statements ending in an optional else. When a condition is true, the code block executes and the ladder exits. The example below turns on a green LED if the temperature is less than 35, an orange LED if the temperature is between 35 and 50, and a red LED if the temperature is greater than 50. So we can see this structure here, which is looking at those three conditions. This can be replaced with the if-else ladder. So if this condition is true, we turn the green LED on and then we exit the ladder. If this is false, then we check if the temperature is less than 50. If it's true, orange LED comes on, else the red LED comes on. So this if-else ladder is an easier way of coding. The switch statement is similar to the if-else ladder and is used to execute selected blocks of code. The general form is we have a switch and a variable located inside the brackets. This variable is compared to a list of case values. If they match, the code inside the case is executed until a break is reached. Then the code will exit the switch statement. If the case does not have a break statement, then the flow of code will fall through to the cases below until either a break or end of the switch statement is reached. The variable in case must be the same type and can only be character or int. You can have an unlimited number of cases, but each case should be unique. And you can have an optional default case at the end of the switch. The default statement is performed if no matches are found. So this example here, pin A is the variable, and we will match pin A against the cased statements. If they are the same, then the block of code within the case and break is executed. The for loop will repeat a section of code for a predetermined number of times. The general form is the for command, initialization of the loop variable, a test condition, and we stay in the loop while the test condition is true, and increment or decrement the loop variable, followed by the curly braces to show the beginning and end of the for block of code. In this example here, we are assigning x and making it 0. We will stay in the loop while x is less than 11, and then we increment the code. Once again, if you don't have the curly braces, then only one line of code is within the if statement. The while loop will run the code within the loop while the test condition is true. The test condition is evaluated at the beginning of the loop, therefore it's possible the loop can be bypassed without first ever entering it. The general form is the while command, followed by the test condition and the curly braces to show a block of code. In this case here, we can see that while count is not equal to 0, we stay in this loop, progressively decrementing count. Now, it can also be used to wait for an action to occur. In this case, the line of code here is within the semicolon. There is no code. This will simply wait for this condition to become true. So therefore, it will wait for the button to be pressed. The do while loop is similar to the while loop. However, the test condition is performed at the end of the loop. That means that this code will always run at least once. C allows us the use of functions. A function is a reusable block of code that performs a specific task inside the program. They improve code development, organization, readability, and reusability. The general form of the function is the return type, the function name, the parameter list, and the curly braces here that show the start and the end of the function. The return type specifies the value type the function will return. If no value is returned, the function should be declared void, and the function can only return a single value. Function names. Every program must have a function name main. The other functions must start with a letter or underscore and can include numbers and certain punctuation characters. Use descriptive names in your function naming, including multiple words. However, spaces between words are not allowed. And the naming convention is the same as the variable declarations. My preference is the camel case. The parameter list allows data to be passed to the function when it's called. There are two ways to pass variables to the function: call by value, which passes a copy of the variable. Modifying the variable inside the function does not change the original variable. And call by reference, it passes the variable's address to the function, allowing the function to modify the original variable. If no parameters are being passed to the function, then use void inside the parameter list. Looking at some function examples, Microchip Studio requires main to be declared as an int and no parameter can be passed to it. A second function here is setup. It's declared void and no parameter is passed to it. We have call by value. Here is the function being called. A copy of mic0 is passed to the read ADC. That's stored in channel, and channel is used to set up ATmux. The function returns ATCH, which is returned back and stored in new data. The function called by reference here, data read, we pass the address of new data to the function, which is used as a pointer, and UDRO is used to store the value of UDRO at the address new data. Libraries are sets of functions that perform common tasks that allow programmers to use these functions without having to write them themselves. The functions are grouped into libraries according to the tasks they perform. For example, the math.h library provides mathematical functions. The library may have functions that can access the operating system. To use a library, use a precompiled directive #include. Microchip Studio has 35 libraries. The common ones are avr.io.h, which defines the internal registers, AVR interrupt.h, which holds the interrupt functions, util delay.h, which includes the delay functions. Microchip Studio provides 35 libraries. Some common libraries you may have used would be mass.h, standard IO, standard libraries, strings. But a lot of the other libraries you will not have used. They are unique to the microprocessor, microcontroller. You would need to look at the technical information on data sheets to see what functions are in the libraries and how they are used.